Hello Year 11 and welcome to our third and final video here for our ninth topic. We have been looking at the language of probability distributions and we looked at expected value, or if you like mean, in our last video. Today we're looking at variance and standard deviation. Now these are both measures of spread, right? They tell us how much variation, how much change, how much difference there is within our different values. Now, here's another example. Maurice and Minerva. Maurice and Minerva are both asked to cut 20 pieces of timber to be 300 millimeters long. Okay, they've been given a task, 20 pieces of timber, cut them 300 mils long. Unfortunately, neither Maurice nor Minerva does a perfect job. Maurice cuts 10 of them at 290 and 10 more at 310 millimeters. You can see you got the mean right, the average length. That's great, was 300 mils. Minerva cut 10 at 295 and 10 at 305. Once again, the average length of those pieces of timber, sure, spot on. Doesn't mean they did a good job though. Could we say that someone did a better job than the other? Who was more accurate? Well, of course Minerva did a better job there. Hers were closer to the mark. But let's say it's not so uniform as all of that. We've got scores spread out all over the place. We need to find a better way of measuring the deviation, the change, the difference between the mean or the expected value and all of the other values that could occur. Now, Maurice's cuts deviated by 10 millimeters. They were supposed to be 300. Some were 10 mils short, some were 10 mils long. Minerva's deviated by 5 millimeters, all of them. We're not really interested in whether they were long or short, just how far away they were from what they were supposed to be. So, look, I can calculate the deviation of each value from the mean. That's pretty straightforward. We calculated the mean the last exercise. And then we just take the value, subtract the mean. Now that could be a negative and I don't want a negative, so we square it. That will definitely make it positive. It also means that the bigger deviations sort of get a bit exaggerated, because when we square a number, the bigger ones get bigger faster. Now, so we've found the deviation, the difference between the value and the mean. Then we're going to square it, and then we're going to weight it in the same way that we weighted all of our values to calculate expected value, right? We take that squared deviation and we multiply it by the probability. Right? So we've subtracted the mean from the value, then we squared that number, made it positive and probably made it bigger. Then we multiplied it by the probability. Then, just as we did with expected value, we add all of those together. We take the sum of those. So this is what we have here, the sum of the square of the deviations multiplied by the probabilities. And this figure here that we produce there is called the variance, right? That's a measure of how much spread there is in those values. Okay, that's the variance. Now that's not the only way to calculate it. I'm not going to go through how we arrive at these different calculations. This is what we just spoke through here though. Deviation squared multiplied by the probability, and then we add those together. Right, this is just another way of saying exactly the same thing. This is the expected value of the square of the deviations. That should probably be a lowercase x there, I think. So we do that. Now there is another calculation that tends to make life easier. We square the values. We find the expected value of those. So we square the values, right? Not the deviation. We square the values, we multiply them by the probability, and we add those together. Okay, so that's a bit like expected value, but we square them first. And then we subtract the square of the mean, or the square of the expected value. Now, this is usually a more straightforward calculation. Both of these ways work just fine, but this one here at the bottom is probably the more straightforward one, and I'll demonstrate that in an example up here. Now, I did promise that we were also going to learn about standard deviation, and very simply, standard deviation is the square root of the variation. You just calculate the variation as we just did there, and you take the square root. So here's an example. Watch out, this gets a bit wild. Regular six-sided die is thrown, number on the uppermost face is observed, right? We just look at the number on the top. Now, I'm asked here to calculate the mean and variance and standard deviation of this distribution. This really is a summary of this whole chapter, right? These are the three main things that we need to do. Calculate the mean, also called the expected value. The variance, that's not called anything else, just the variance. And the standard deviation, regularly abbreviated with this lowercase sigma. So, here we go. Those are our values, 1, 2, 3, 4, 5, and 6. And the probability of those values, it's uniformly distributed, so they're all 1/6. And I just check if I add all 6 of those together, I get 1. That's great because my probabilities have to add to 1. Now, I need to find the mean. So we do the the value multiplied by the probability, right? So 1 times 1/6, 2 times 1/6, and so on. I didn't simplify those because we have to add them up, right? It's easy with the common denominator. So I add those up and I get 21/6. So the mean or expected value of this distribution is 21/6. Now, we are going to use the first method here for calculating the variation. So it is, right, it is the value minus the mean. So 1 minus 21/6. Or, it doesn't really matter if I do it the other way around. I've done it the other way around, 21/6 minus 1. They're going to get squared, so it doesn't matter, but I'm a little embarrassed to do that back to front. So one way or the other, we take typically this the mean from the score, but as I say, when we square it, you see the symmetry here, it'll all even out. So 15/6, 9/6, 3/6, negative 3/6, negative 9/6, negative 15/6. Right, so that's the deviation, right? The difference between the score and the mean. Now I square those numbers, so 15/6 squared is 225/36, and you can see there the negatives disappear. So whether we were positive or negative, it doesn't matter now. So they're the squares of the deviations, and now we need to weight those by multiplying by the probability. So 225/36 multiplied by 1/6. 81/36 multiplied by 1/6, 81 on 216, and so on. So now they're weighted, and then I add those together, and that's my variation. So we found the deviations, right? This row here is my deviations. Then we square those deviations, then we weight them by multiplying by the probability, and then we add them up, and then I simplified it, we get 35/12. Okay, that's the variation. So we were asked to find 3 things, we found 2 of them. The mean was 21/6, and the variation is 35/12. But there was another way of calculating these, and just while we're going, I'm going to show you how you do it. So I've just grayed out those things because we're going to pretend we didn't do that much. We just have the values, the probabilities, and then we weighted the probabilities, we weighted the values to get the mean, or the expected value, because I still need that for this next calculation. This time I've squared the values. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36. So we square the values, and then I weight those, right? Multiply the squares by the probabilities, and I get 91/6. And so that is the expected value of the square of the values. Now, the variation can be calculated this way. it's that figure there, the expected value of the square of the values, minus the square of the mean. So 91 on 6 minus 21 on 6 squared. And that gives us 35 on 12, just as we calculated it the other way around there. So there's a few steps there. It takes a little bit of remembering, but you know, comes together okay. Practice them a few times. Now, we were asked to find 3 things. We've found 2 of them, one of them twice. We've still got to find the standard deviation, and that's not terribly complicated. The standard deviation is the square root of the variance. So it's just the square root of 35 on 12, and those not being square numbers or anything much that cancels, nothing much going on there, we can roughly evaluate that to 1.7078, 4 decimal places, using our calculator. So that's the approximate standard deviation, about 1.7. Now, some of these calculations, do on your calculator. Be careful with rounding. Okay, if you introduce rounding errors when you are squaring things and adding them together and taking square roots and whatever else, those small rounding errors can compound pretty significantly. So be careful. This second method here, the one that's not grayed out, you can see it sort of used fewer fractions along the way. Okay, because we're squaring things as opposed to doing subtractions, right? They are more likely to end up as fairly neat numbers, and that's one of the big reasons for doing it that way. So just a reminder there, we squared the values, then we weighted them, multiplied them by the probability, added those up, and subtracted the square of the mean. Righto, we've covered a few things there. There's certainly a lot of language there, and I know I get tied up in a little bit sometimes. Big X's and little x's and whatever else. But that's it for the topic. Really what we've done is we have calculated the expected value, the variance, and the standard deviation. That's the big thing. So variance is a measure of spread, right? And this is probably the most straightforward way to calculate it. Whichever way you do it, won't be wrong. Standard deviation is another measure of spread, tells us how spread out things are, and that's just the square root of the variance, sorry. Right, that's it. That is it for probability distributions, or at least discrete probability distributions. You might remember right at the beginning, we talked about the difference between discrete and continuous. Well, continuous probability distributions introduce a whole nother level of complexity, and we'll learn about that in year 12. Okay, if you've got any questions, you know what to do. Ask me in class. Okay, otherwise, see you soon.